Good morning, sir.
Good morning. Good morning.
Good morning, sir.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning, sir.
Good morning. सबके सब नींद में हो. आवाज. Early in the morning, if you have a shower, the voice will be booming. People don't have a shower early in the morning.
Yes, sir. Sir, it is
Sir, ठंड बहुत है, sir.
cold.
See, listen.
बहुत ठंडा
The
है, sir.
difference between the voices. Good morning, sir.
Good morning, sir.
Good morning.
Good
Right.
morning, sir.
Good morning, sir. कितना difference है दोनों?
सर 15 मिनट पहले उठे सर. शॉवर कहाँ से?
नहीं
सर,
वो अलग
बहुत
बात है.
है.
सर आधा घंटा पहले उठ के भी नहा के आया।
सर बहुत ठंडा है सर. बहुत ठंडा.
ठंड तो मेरे लिए भी है यार.
5:30 को उठा फिर भी नहीं सर. सर आप बहुत स्ट्रांग है सर. हम लोग इतने स्ट्रांग
कुछ
नहीं.
भी.
सर कितना भी जल्दी सो सर 7 बजे के पहले उठना होता ही नहीं सर.
सर अभी तो इतना होमवर्क है सर.
All I asked you is to come fresh to the class. Right?
Yes sir.
फर्क है. 7 बजे उठ नहीं पाएंगे. 7 बजे क्या लेना देना है यार. Is there a lag in the video?
नहीं सर एकदम ठीक
नो
है.
सर.
Hang on. Now listen. Today we are supposed to learn variable mass. People are
Yes.
yet joining. अभी उठ रहे हैं कुछ लोग. उठ के डायरेक्ट कैमरा ऑन कर देंगे. I mean zoom ऑन कर. कैमरा ऑन नहीं कर.
करा दिया सर.
नहीं सर, इतने में खराब नहीं है.
Somebody is typing, should we do assignment subjective first or exercise 4? Either way I am okay. Either way I am okay. No issue. It's all how you are comfortable. Assignment का subjective questions will be very tough. उतना तो ध्यान में रखो. Yeah, I will take doubts next week. I'll be starting from, if I'm right, HCV का कुछ doubts हुआ है आप लोगों का या booklet 1 का. जहां तक हुआ है वहां से catch.
Yes.
कल का लेक्चर कैंसिल है या डाउट्स लोगे?
आप सब मिलके जो बोलेंगे.
कैंसल.
तो कैंसिल कर दो. हम लोग को सेल्फ स्टडी के लिए दे
कैंसिल
दो.
करेंगे बीच में जब स्ट्रेंथ ऑफ द क्लास इज मैक्सिमम, बीच में ऑलरेडी 106 है. जनरली 120 से ज्यादा नहीं आते आपके. अब नींद में होंगे, बीच में याद दिला देना, वोटिंग करेंगे. व्हाटएवर यू पीपल से. एंड हाँ, I have kept the timetable in charge informed next week to give you at least 1 day of a complete gap to cope up with your backlogs.
Thank you, sir.
Thank you sir.
थैंक यू.
मिलेगा complete gap, right? And that day don't sleep. ठंड का सीजन है. नंबर ऑफ एक्सक्यूजेस नहीं. सुबह 7 बजे अलर्टली उठ जाना चाहिए. पूरा दिन यूटिलाइज करो आपको बैकलॉग खत्म करने की.
Yes sir.
Right? You destroy your that day, I'll not be able to help. और मेजर टेस्ट के लिए प्रैक्टिस टेस्ट सैटरडे को कंडक्ट करेंगे.
ठीक है सर.
सर उसकी पढ़ाई कब कर एमटी की?
वही सर उसकी पढ़ाई कब करेंगे ना.
तो बीच में एक दिन का गैप किस लिए दिलवाया यार?
होमवर्क के लिए.
Friday
क्लॉक के लिए ना सर.
वही तो है.
COM है
प्रैक्टिस टेस्ट
एमपी में।
करके आपको समझ में आ जाएगा कौन कौन सा टॉपिक्स पर मुझे कंसंट्रेट करना है, उस पर मेजर टेस्ट का तैयारी कर।
हाँ तो ये अच्छा आइडिया है, ऐसे ही करेंगे।
थैंक यू।
थैंक यू सर।
Thank you, sir.
Thank you, sir.
अब सुनो, टुडे वी डील विद वेरिएबल मास। Consider a body of capital M mass moving with a velocity of u. Rocket, conveyor belt with sand, truck carrying sand where sand is filling continuously. All these are variable mass. Hose pipe, water pipe, if you are ever watering the plants. Hose pipe, normal water pipe, when you use that to water the plants, water is going ahead, pipe will be pushed backwards. जो फायर इंजन का होस पाइप होता है, वाटर विल बी एजेक्टेड एट वेरी हाई स्पीड्स। फायर इंजन का होस पाइप अगर आप लोगों ने कभी देखा है,
Yes, sir.
pipe will be ejecting water at very high speeds because the water should reach greater heights.
Yes sir.
The number of people who will hold that pipe is not one. There will be at least 2 strong men holding it tight because it will bounce back. They're trained for it. Right? You normally try to catch hold of the hose pipe, you will fly back along with it. They take support, they take a hold, they take support and then hold the hose pipe. Well built, 2 men at least will be holding the hose pipe if the water jet cannon should leave water to a very high altitude. Right?
Yes.
Capital M is moving with a velocity of u. It ejects delta M with a velocity Vr, and it is left with capital M minus delta M. Now capital M will move with a velocity u plus delta E. There is no external force on this system. There is no external force on this particular system. Right?
Yes sir.
So that means momentum of this and this should be conserved. It's a rocket somewhere in space. It's a
Yes.
rocket somewhere in space. There is no external force on whole of the system.
Yes.
Capital Mu is equal. When you know that you will have to conserve momentum with respect to ground or inertial frame, why are you taking this as relative velocity with respect to this? For practical reasons, I will never be able to measure this velocity. Rocket is somewhere in space. It is ejecting gas. From ground, how will I measure its speed? But sensors fit behind the rocket will tell us the speed of the exhaust gas. So rocket will be able to decide the speed of the exhaust gas. So in practical reasons, I can measure relative velocity of delta M with respect to the leftover mass. Hence, I gave you VR. But to conserve momentum, I'll have to convert that velocity to with respect to
Ground friend.
And
so delta M into velocity of delta M with respect to this plus present velocity of this with respect to ground. VR plus U plus delta U. Capital M minus delta M into U plus delta. Now you may ask, if this ejects in the forward direction, it will experience a force in backward direction.
Backward.
How did you increase delta U? You should have written U minus delta U. If I take U plus delta
Delta U
U,
is
I get a
negative.
negative sign.
Negative value, yes.
Delta U will be negative, right? First equation, is it clear to all? Total initial momentum, total final momentum, take all velocities with respect to ground. Delta M velocity, you gave me relative velocity, translate it with respect to ground and conserve momentum. So far, so good, all of you.
Yes, sir.
Now all I will do is multiply and open this. Delta M into VR plus delta M into U plus delta M into delta U plus M into U plus M into delta U minus delta M into U minus delta M into delta. I have just opened up the bracket. No big deal. Capital M into U. Capital MU, capital MU. Delta M into U, delta M into delta M, delta U, delta M, delta. Capital M delta U will be equal to minus BR delta. Capital M delta U by delta T is minus BR dm by D. This is called the thrust force, sometimes called as impact force, more colloquially referred to as thrust force, Ft. M into A is minus VR dm by dt. Dm by dt is the rate at which mass is being ejected. Vr is the relative velocity of the mass with respect to capital M minus delta. Now you people can see here clearly. You took plus delta U, you are getting delta U negative. You just conserve linear momentum in the direction. The sign will take care of itself. Or in other words, I'll put it this way. This thrust force is opposite to direction of VR if mass is decreasing. Thrust force is in the direction of VR if mass is increasing. Mass is decreasing, thrust force will be opposite to direction of relative velocity. How do I remember this? Rocket propulsion. From a rocket, gallons and gallons of gas is given as exhaust to lift the rocket. The relative velocity is in the downward direction. Thrust force will be in
upward
Upward.
direction.
So when the mass is decreasing, thrust force will be opposite to, now I took mass decreasing. I got thrust force opposite to direction of VR. If you take
Yes.
mass increasing, thrust force will be in the direction of VR. Right?
Yes.
Sir, can you explain that first step? I just joined a bit late.
Conservation of momentum. Capital MU, there's no external force. The rocket is
Yes,
somewhere
sir.
in space.
Yes, sir.
So there is no external force, means momentum of this and this should be conserved. Right? Capital MU is the initial momentum. Final momentum of delta M. Relative velocity should be bought with respect to an inertial frame. Velocity
Delta M is that is the gas that is emitted from the rocket, right?
It may be gas, it may be water, it may be continuous bullets, it may be anything. Sand spilling out of a truck.
Okay, sir.
Delta M is the mass being removed from here. VR is with respect to this, convert it with respect to ground, and then conserve linear momentum.
Okay, sir.
Remaining is
So-
only simplification.
So, in our example, we have taken dm by dt to be decreasing, right?
Right?
Oh.
That's why M is decreasing, thrust force should be opposite to VR. When M is decreasing, I'm getting thrust force opposite to VR.
Yeah.
I'll put the same thing in another way where you will have much better clarity. Take it down till here.
Sir,
Hmm.
so I'm not getting one thing. If velocity with respect, like VR is downwards in case of a rocket, why are we taking VR plus U plus delta U?
VR is with respect to the rocket. Velocity of the mass with respect to the rocket plus velocity of the rocket with respect to ground. Now, get the velocity with respect to ground. There VR will be negative.
Ha, so why don't we write minus sign ke saath idhar?
I
Or
take
the
it in direction, where if I take it in the backward direction,
Huh?
it's a negative sign. I have no problem.
You've taken here in the forward direction.
Forward.
Okay, okay.
For me, all these three momentums are along the positive x-axis. So all are positive. If the direction I've taken is wrong, if I calculate VR, I'll get a negative sign.
Okay, sir.
Here, the thrust force which I am getting is opposite to the direction of VR. That means thrust force will be in backward direction, which actually I can visualize. If there is delta M ejected like a rocket, see, I'm holding VR is in the forward direction. VR you have taken in the forward direction. So hose pipe, when you are holding it, relative velocity is in the forward direction. Thrust force will be in
Backward.
Backward direction.
आया कि नहीं opposite direction.
Ha, sir. Ha, sir.
I took VR in that. Technically, I should write delta M here. That means it is more like firing a bullet in the forward direction. I am getting thrust force in backward direction, and which I got. I have taken the wrong direction, so I am getting the negatives.
Sir, is this the first slide you have written or something also you have written? Because I have joined
First
late,
slide.
sir.
Now, people
Net
who have
connection
joined
was
late
poor.
in this class comfortably, they're announcing that I have joined late. Technically, you deserve punishment, right?
Yes, sir.
Sir,
People
the
who have
network
joined late,
connection was weak, sir. Sir, net
जितना
connection was not.
मिनट लेट ज्वाइन किया उतने सिटअप्स करके वीडियो मुझे भेज दिया कर, राइट?
सर अभी नहीं करना था?
Yes, sir. Yes, sir.
ऑन द स्पॉट
Yes, sir.
करने को बोला
अब
सर.
ऑन द स्पॉट करेंगे तो इंस्टेंटली आई विल क्लियर योर डाउट. ये फर्स्ट स्लाइड है कि सेकंड स्लाइड है बता दो. राणा ने माइक ऑन किया, वेरी गुड. पूरा स्वेटर वेटर लगा के बैठा हो, बहुत ठंड लग रहा
दादाजी
है.
दिख रहे.
हाँ सर, वो थोड़ा 15 डिग्री सेल्सियस और मुझे फीवर भी था थोड़ा, तो इससे.
बाप रे. हाउ मेनी मिनट्स लेट डिड यू जॉइन?
सर 10 मिनट्स लेट.
Oh, बाप रे. 10 sit-ups, quick. You people are young enough. 10 will be very easy.
यस सर.
1, 2, 3, 4, 5, 6, 7, 8. कंसेशन तुम्हें अच्छा किया है, बस काफी. बाकी एक और बंदा बताया था कि बीच में ज्वाइन हुआ, कौन है? नाम क्या है उसका?
विनायक.
विनायक
विनायक का नाम लोग बहुत प्यार से लेते हैं यार. इस बंदे को देखना है. मैं काम करूँ यार.
यार, लेकिन सच में वही था.
विनायक माइक ऑन करो कि मेरा.
सर, नेट कनेक्शन वीक था सर मेरा, वो इसीलिए सर नेट प्रॉब्लम.
ये तो
हाँ
हर
ना,
बार झूठ
अभी ठीक
बोलते
है.
हो यार. समथिंग और द अदर करके यू कीप स्किपिंग ऑफ.
सर क्या बताऊं सर,
कर
वही
दूंगा मैं.
रीजन ही है.
Next time you talk म्यूट कर दूंगा. यू स्विच ऑन योर कैमरा, नॉट एक्सेप्टेड. तेरा चेहरा देख.
मतलब देखो ना, लोग यहाँ पे
सर नेट
स्पॉटलाइट
भी
के लिए
उसका ही था
मरते
ना,
हैं,
उसकी
विनायक को
प्रॉब्लम.
इतना स्पॉटलाइट मिल रहा है,
विनायक,
वो नीचे.
हाँ विनायक, नाउ लेंस इज विजिबल. कम ऑन. हाउ मेनी मिनट्स लेट डिड यू जॉइन? अरे ऑडी कार दिखा रहा है विनायक. आई डोंट माइंड. तो ऑडी कार खरीद के देगा तो आई विल बी मोर देन हैप्पी. आई डोंट वांट इट.
यस सर.
ऑडी Q3 थोड़ा मेरा चॉइस भी देख. Q3
सर ये RS7 है.
अरे सर भाग जाएगा ऐसे.
नहीं,
सर
RS7
ऐसे
बहुत
बात तो
कॉस्टली
मत
है.
करो.
नहीं, मुझे Q3 काफी.
सर
Audi
ये आपको
Q3.
फालतू के गाड़ी के टॉक में लगा के फिर आप क्लास करोगे, सेटअप नहीं करेगा.
टॉपिक चेंज कर रहा है.
हाँ सही बहाना मार.
हाँ सर, बहाना बना रहा है.
विनायक तेरा ड्यू है, भूलूंगा नहीं. बस तेरा नाम भूल जाता हूँ यार.
सर
ठीक है
कैमरा तो
sir.
ऑन हो रहा था ना, तो सेटअप क्यों नहीं करना?
Now, can I rub the board?
यस सर।
नो
Yes,
सर
sir.
No, sir, 1 minute.
कोई सजेशन दे रहा है टेस्ला कार्स।
So should it be du by dt in place of delta u?
Very technically, yes. This is du by dt. After writing this, I wrote this. I thought I'll change this. I was feeling lazy. Somebody is asking real life example of mass increasing. 5 minutes में दूंगा. Increasing mass का भी real life example होता है.
Sir, humans are the example of increasing mass.
अब सुनो, same thing. I'll put it this way. Same thing. I'll put it this way. This is capital M moving with a velocity of u. It ejected delta m mass with a velocity vr in the forward direction. So technically now from the previous derivation you understood that capital M minus delta m should slow down. If vr is fired forwards, this should slow down in the forward direction or move in the backward direction. Yes or no? Now
Yes.
I am asking you, what is the external force I should apply on this for it to move with the same velocity? Which direction will I have to apply external force?
फॉरवर्ड डायरेक्शन।
Forward direction. Am I right?
यस सर।
Delta m is being ejected in the forward direction. So thrust force will be in the backward direction. So if I am holding the hose pipe, I should be holding and applying force in
Forward direction.
forward direction. Everybody convinced?
Yes,
यस
sir.
सर।
Yes,
Now I
sir.
am asking you for F external. F external will be final momentum minus initial momentum. Capital M minus delta M, its speed did not change. You are asking me how much external force should I apply so that the velocity will remain the same. That should be equal to the thrust force which we derived,
Sir.
but in forward direction, right? Now let us derive and see if we are getting it. Delta M VR plus U. This is the final moment. Minus capital Mu by delta T. So far, so good. Yes or no?
Sir, here why didn't you take u plus delta u?
तुमने क्वेश्चन सुना नहीं. I asked what should be the external force for the velocity to remain the same.
Achha, yes sir.
When delta m is ejected, this will technically change its velocity.
Yes sir.
But I am now applying an external force for the velocity to remain
Same.
right. Now open up this mu minus delta m into u plus vr into delta m plus delta m into u minus mu divided by delta t. mu will go. Delta m into u, delta m into u will go. F external that I should apply is Vr dm by dt. Here F external you got positive. Why? Direction is in the direction of Vr.
Yes, sir.
And thrust force was in opposite direction. So I should apply a force equal to the thrust force in opposite direction. Thrust force was backwards. So F external is in the forward direction.
So इसका question बोल सकते हैं एक बार?
What is the external force I should apply for capital M minus delta M to move with the same velocity?
Okay.
External force that I should apply for capital M minus delta M to move with the same velocity.
सर
हाँ,
सर अगर जब भी हम लोग ये फायर करेंगे तो ये किसी भी ये फोर्स पानी को, तो सर ये m minus delta will be lighter than the whole mass of m, right? So its speed should be greater than you, right?
बिल्कुल नहीं. If
Hmm.
delta M mass leaves the hose pipe,
Yes, sir.
the mass of the hose pipe will decrease by exactly the same value, delta M.
Yes, sir. So what I doubt, like, why should the FX term should be applied in the forward dash? That's what doubt.
फिर से बोलो, I didn't get it.
Sir,
तो वो
the
पूछ रहा है फॉरवर्ड डायरेक्शन में फोर्स क्यों अप्लाई करना है?
अरे भाई, ये momentum forward है, ये momentum forward है. Difference in that momentum will be in forward direction. I have no choice. When you take this, इसके सामने क्या लिखोगे? I cap.
हाँ सर,
इसके सामने भी I cap.
I
इसके
can.
सामने भी I cap. Difference तो I cap ही आएगा. Minus I cap थोड़ी आएगा.
ठीक है सर.
People are not listening to the class. Samit is typing, why didn't you take U plus delta U? Question तो सुन लो, अब तक 10 बार question बोल चुका हूँ. Question is about how much external force you should apply for this to move with uniform velocity. तो U plus delta U कैसा ले लूंगा यार? U remain, it should contain only U. The speed should not increase. To prevent the speed from increasing, how much force should I apply? I actually know the answer. It should be equal and opposite to the thrust force. I derived it to consolidate on what we did. Question नहीं सुन रहे हो यार तुम लोग, आधा आधा सुनते हो.
Done, sir.
सर एक मिनट.
Can I rub the board?
Yes.
यस.
This is a long car. I am pulling this with a force of F. At time t equal to 0, mass of sand in the car is m0. Total mass of the car plus sand is m0. At time t equal to 0, from the funnel, you have got sand spilling into at a rate of mu kg per second. Sand spilling into at the rate of mu kg per second. So your mass is
Variable increasing.
increasing. Variable it's variable. Mass is increasing, right? If mass is increasing, what did I tell you? Thrust force will be in the direction of
The
relative
direction of-
velocity.
Yes.
Relative velocity of the incoming mass with respect to this. You are writing the dynamic equation for this. You started applying force F at time t equal to 0. At t equal to 0, F is applied. At t equal to 0, mass of car is m0. At t equal to 0, sand starts spilling into the car at the rate of mu kg per second. So far, so good. Yes or no?
Yes, sir.
Yes.
Yes.
Now, what you will calculate is after time t, you are asked to calculate velocity of the cart as a function of time. Find velocity of cart as a function of time. That's your question. Right? After time t, in a short time interval dt, let the velocity of car be v. Are you okay with this till here? Say something.
Sir,
Yes.
sir,
This force is a constant force. हाँ बोलो.
सर जब मास एड अप हो रहा है तो थ्रस्ट वेलोसिटी के डायरेक्शन में इसको इमेजिन कैसे करना, मतलब इंट्यूटिवली?
Yes, sir.
Temporarily it will be difficult, but understand one thing. Imagination of that, I would say how to remember it. Opposite of rocket propulsion.
अच्छा, ओके सर.
Or listen, I'll put it easier for you. This dm is falling vertically. What is its horizontal velocity?
Zero.
Zero.
यस सर.
Truck is moving in the forward direction. So
Yes, sir.
dm mass, listen carefully, you'll get your answer. Dm mass, when it falls in the sand, force on the dm mass will be in which direction? In this direction?
Yes, sir.
Reaction by the dm on the cart will be in,
Opposite direction.
right? I'll establish this, have a look at it. You made this go one step ahead, but it's okay. Listen, there is dm mass falling vertically downwards and the cart is moving with a velocity v. I will redraw the diagram here for your convenience. All of you please visualize. One way of telling me the direction of the thrust force is, have a look at it. dm mass has zero velocity in this direction. dm mass is falling vertically.
Yes, sir.
Yes, sir.
All of you, I need your attention. What he asked is a very intricate point. Listen to me carefully. dm mass is falling vertically. If I were to solve the problem, what I will do is blindly go by the fact that mass is increasing. Relative velocity of dm with respect to this is in this direction. Vr will be equal to v. Because horizontal velocity of dm is 0. Velocity of dm with respect to capital M is 0 minus velocity of capital M minus v. So relative velocity will be in backward direction.
Yes, sir.
Now what I would say is, mass is increasing, directly take the thrust force in the direction of Vr. Mass is increasing, thrust force is in the direction of Vr. Agreed? This is what is my logic. Now, one of the boys' doubt was, how do you want me to visualize this force? Dhyan se suniye. dm mass, when it falls into this, it will start moving in the horizontal direction with the same velocity as that of the car. Yes or no?
Yes, sir.
Yes.
So
Yes.
that means on dm mass, the force is in this direction. On the car, force will be in
Backward.
equal and opposite.
Yes.
So thrust force The logic which I used mathematically and the physics, are they in sync?
Yes, sir.
Yes,
Can you
sir.
repeat the last point?
DM mass, when it falls into the sand, for it to start moving with the same velocity as that of the cart, force on the DM mass should be in which direction?
Forward.
Yes, sir.
Reaction by the DM on the cart will be in?
Backward.
Backward.
That's what I said. Mass is increasing, thrust force is in the direction of VR. Mass is increasing, thrust force is in the direction of VR. Either follow this or go into the free body diagram of DM and see it. Either way, you should get the same. But I'm yet to solve the problem. I just give you the direction of FT. Take it down till here. I need the board to solve the problem.
Yes.
तो एक बार एग्जैक्ट क्वेश्चन रिपीट कर सकते हो प्लीज?
Pardon?
क्वेश्चन रिपीट कर सकते हो एक बार?
We'll have to find out the velocity of the cart. You are pulling the cart with the force of F. You applied force at time t equal to 0. Sand started spilling at time t equal to 0. At time t equal to 0, mass of the cart is unknown. So after time t, as the sand is spilling into, you want the velocity as a function of time.
Okay.
How will I get the velocity if I know the net forces acting on it? My mathematical logic was, if mass is increasing, thrust force is in the direction of relative velocity of the sand particle with respect to the car. Sand particle falling vertically. That means its horizontal velocity is 0.
0.
So 0 minus velocity of the cart, and getting minus v. So relative velocity of the sand particle with respect to the cart is in
Backward direction.
So mass is increasing, thrust force is in the direction of VR. This is the way I put it. You want to see the physics behind sand particle. When it falls in the cart, it starts getting a force in the forward direction to go with the velocity v in that direction. Reaction by the sand particle on the cart will be in backward direction. after time t in a short time interval dt, let the velocity of the cart be v, which we have to calculate.
Sir, initially at rest.
Initially at rest. At time t equal to 0, velocity is 0. At t equal to 0, velocity of car is 0. I'll solve this problem. First take down the question and the logic as to why Ft or thrust force on capital M is in the backward direction. So far, so good. Can I rub this part of the board and solve the problem?
Yes, sir. Yes, sir. Yes, sir.
So the cart is initially at rest. Don't forget that. And you know now the value of the thrust force. It is Vr into dm by dt. You even know the direction. Now, your dynamic equation is F minus Ft is equal to m naught plus mu t into dv by dt. See if you are convinced with the first step. Net total force is mass into acceleration. What is the mass of the cart after time t in a short time interval dt after time t? How much additional mass was added to the cart?
Beauty.
Into acceleration. First step, is it clear to all?
Yes, sir.
Vr is V. Vr is velocity of dm minus velocity of capital M. Velocity of dm in the horizontal direction is 0. Minus velocity is V. Velocity of the car. V mu dm by dt. Or I'll write that step also. dm by dt is equal to m naught plus mu t into dv by dt. F minus mu v is m naught plus mu t into dv by dt. F minus mu dt by m naught plus mu. At time t equal to 0, what was the velocity of the car?
0.
At time t equal to t, I want the velocity as a function of
Time.
integration of this is ln of f minus mu v upon minus mu 0 to v. This is ln of m naught plus mu t upon mu 0 to t. Right? Mu and mu will go, there will be a negative sign. Ln of f minus mu v upon f will be ln of m naught by m naught plus mu. क्या किया यार तूने? I substituted limits. Ln a minus ln b is ln a by b. So here ln b by a क्यों डाला यार तूने? Because of this negatives. Because of this negatives. Now actually I'm running short of space here. You will remove ln on both sides, cross multiply and find out velocity as a function of time. Can you?
Yes, sir.
Yes, sir.
I am waiting for you. The next problem will be all yours.
Sir, sir, where is the negative sign because of which you had to take the reciprocal? Oh, is it two? ठीक है वहाँ.
यहाँ माइनस में हुई है तो when I integrate this ln of this divided by the differentiation of that.
Yes, yes.
So 162 students in the class. You have to vote for one particular situation. Tomorrow, do you want time to solve your homework?
Yes, sir.
Yes, sir.
Having
Definitely.
clearing doubts, or should it be 1 second? Don't start voting right now. 1 second, wait. Right? The voting is being done for how many of you will attend a lecture tomorrow if I keep a doubt lecture tomorrow morning? How many of you will attend? I put it in a different way. Listen to me carefully. If I take a doubt lecture, how many of you will attend the doubt lecture?
Sir, I will attend, but that doesn't mean I want to attend.
हाँ वही sir.
Yes, sir. वही.
मैं
मैं
like
तो
Most
मतलब
important
change
point
will
है
to want.
doubts को
सर मैं तो करूंगा ही नहीं
सर
attend,
अटेंड
सर।
करना ड्यूटी है पर करना नहीं है.
हाँ वही.
You need time to solve your homework.
Yes.
हाँ सर.
टाइम चाहिए सर बहुत बड़ा.
Tomorrow morning's class is cancelled.
Thank you.
Thank you, sir.
Right?
Thank you.
Given the time, don't sleep and waste your time. Please complete your homework.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
yes
Homework.
sir.
You don't, I get up early in the morning, so I'll be free. I have all your phone numbers on the group. Arbitrarily किसी को भी फोन करके पूछूंगा क्या कर रहे हो आप.
Sir,
अब
homework
ये
उठा दो हमें.
बोलो कौन है ये नहीं पूछने का. Spontaneously you'll have to tell me, sir, I am doing so and so thing. Is that clear?
Yes, sir.
मेरा कुछ
हाँ,
काम है
sir,
नहीं.
हाँ.
एक एक
एक्साइटमेंट की
बंदे
वजह
को
से
फोन
आपके
करूंगा
फोन
कल
का
सुबह.
इंतजार है.
हाँ सर इसमें कोई को
सर फोन
दिक्कत
का
नहीं है सर.
इंतजार
होमवर्क तो करना
करेंगे
है.
सर. सर आपके फोन का
सर
इंतजार
सुबह तक
करेंगे.
रात होमवर्क.
Sir, we'll be eagerly waiting for your phone call.
वो so sweet
हाँ
of you.
सर.
I have no job. सुबह सुबह उठ के कॉफी पीने के बाद कुछ काम है नहीं. तुम लोगों को फोन करूँ.
Sir, any tip on getting up early?
Pardon?
जल्दी उठो.
Sir, any tips on getting up early?
1.5 साल बाद पूछ रहे हैं any tip on getting
Get
up
up
early.
and pour cold water on your
मम्मी को
face.
बोल
Works
थप्पड़
wonders.
मारने.
या
अच्छा
मम्मी
idea.
को बोल देना चप्पल झाड़ू बेलन जिससे हो उससे उठाने के लिए जबरदस्त उठोगे.
हाँ सर.
सर उससे भी नहीं उठता सर मैं.
कुछ भी.
घूम कर है क्या?
Sir, so ये FT का
You can
आपने
try
फॉर्मूला
14
सब्स्टिट्यूट किया है ना VDM by dt.
फिर से बोलो.
FT का ये आपने फॉर्मूला सब्स्टिट्यूट किया है ना VDM by
हाँ,
dt.
VDM by dt. These we are relative velocity.
हाँ, so V is minus V, right?
Right?
तो
अब
Plus-
माइनस v के वजह से आपको डायरेक्शन ऑफ रिलेटिव वेलोसिटी आ गई. Relative velocity is in the backward direction.
हाँ,
Now, what did we conclude? If the mass is increasing, thrust force is in the direction of relative velocity.
हाँ, so वो एक ही बार आएगा minus sign.
हाँ, if not,
हाँ.
do one thing, right? F plus ft is equal to m into dv by dt. ft is minus v. I'm okay.
हाँ.
either दो बार नहीं ले सकते. It's like body is decelerating. You will take s equal to ut minus half at square.
और
and
वापस
then put your
minus है.
negative. You will be
हाँ,
easy.
हाँ, 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 समझा.
Next problem you will solve.
So, सर अगर डीएम की वेलोसिटी डाउनवर्ड्स भी काफी सिग्निफिकेंट होती देन वुड हैव एफटी बी एन
I answer your doubt. I will be giving you the hint for the next problem. So wait for 2 minutes. You destroyed the suspense of the next problem. Right? Now, what is the next problem? This is a sand car. You apply force at time t equal to 0. Here, everything starts at time t equal to 0. At t equal to 0, cart is at rest. Cart is at rest. At t equal to 0, mass of the cart is m0. At t equal to 0, sand starts spilling out at the rate of mu kg per second. At t equal to 0, you applied a force of F. At t equal to 0, F is F. Find the velocity of the cart as a function of time. Find velocity of cart as a function of time. First, tell me the direction of thrust force. I will write after time t. After time t, in a short time interval dt, v is the velocity of the cart. Now, after time t, do not shout your answers. Type in the chat box and type to the host, not co-host. Direction of thrust force.
The direction of thrust force on the dm particle or on the m0 mass?
On the car. Obviously, you are writing the dynamic equation for the car. Four students got it right. Backward and forward both are wrong. Only 4 students got it right. In the horizontal direction, thrust force is 0.
Yeah.
हाँ सर वही तो नीचे जा रहा है.
In the horizontal direction, thrust force is 0, right? If ever this has sufficiently large velocity, thrust force is in upward direction. You push the sand downwards, the cart will fly upwards.
Rocket की तरह.
Right? This is like rocket propulsion. In the horizontal direction, there is no thrust force. Why is there no thrust force? Sand particles spilling out of the cart will have the same horizontal velocity as that of the cart.
Yes, sir.
Sand particles spilling out of the cart will have the same horizontal velocity as that of the cart.
Yes, sir.
Velocity of the sand particle and the cart in the horizontal direction is the same. So what is the relative velocity in the horizontal direction? Zero. So thrust force is
0.
Sand is spilling out. If you keep a piston here and push the sand outwards with greater velocity, the cart will fly upwards.
Yes, sir.
Without the piston, there is another way of making the cart fly upwards. Only Rajnikant can do it.
अच्छा सर ठीक है.
Okay.
You see Rajnikant's movies. He is walking ahead. Behind, cars will be flying for no reason.
Yes.
Right? So unless you give surplus speed to this particular sand spilling out using a piston, the cart will not fly in the upward direction. So here, our job is to solve in the horizontal direction. Horizontal direction, there is only one force. After time t, m0 minus mu t into dv by dt. यार एक ही फोर्स है, कांस्टेंट फोर्स है, कैलकुलस क्यों ला रहे हो यार बीच में? यार मास चेंज हो रहा है.
Yes, sir.
एक ही फोर्स है, कांस्टेंट फोर्स है, right? It is mass into acceleration, but the mass is changing. F minus. Right? Now somebody is asking, but sir, cart will also go towards the right because of external force. Cart, whatever velocity it has got, sand also will have the same velocity in the horizontal direction. Sand is spilling. You are dropping a body from a train. Kinematics may have learned when you were just born.
Yes, sir.
Drop a body from a train. Horizontal velocity of the body and the train will be the same.
Yes, sir.
So the sand particles velocity and this will be the same. So
Yes.
relative velocity will be 0. Now, F, why am I rewriting this? dP upon m naught minus mu t is dv by f. Time t equal to 0, velocity was 0, time t equal to t, I want the velocity as a function of time. I will leave the simplification to your fine judgment. We have done this integration right now.
Sir, on the right hand side, f will come to integral because it's constant, right?
थोड़ा जोर से बोलो यार, सुनाई नहीं दे रहा है.
Sir, f will come outside the integral, right?
Naturally, f is a constant. You can pull it out of the integral.
तो previous sum में why वो velocity पीछे आ रहा था dm का, मतलब इसमें
Find out
forward
relative velocity. When the dm
इसमें
is falling vertically, its horizontal velocity is 0.
हाँ
Velocity of the cart is v. 0 minus v.
हाँ, but here that is opposite case, right? It is falling
Here
from
it
the
is
cart.
similar. Both the sand particle and the cart will have the same horizontal
हाँ,
velocity.
yes sir.
Sir, in that integral shouldn't be from 0 to v.
Yes.
0.
Sir, you said the thrust force is upwards, right? Not horizontally.
Right.
Because of so, but when dm or at mu kg per second is falling, so it's falling with very less velocity, right? Like, cause
Hence the cart is not flying upwards. You
वही.
increase the speed of this, use a piston and push it down like a rocket exhaust, the cart will fly up.
Yes.
So the normal force on the cart is decreased, right? Because of the sand.
Yes. Normal force on the cart will decrease.
Sir, can you explain again how is the thrust force in the upward direction?
रॉकेट प्रोपल्शन यार, गैस नीचे जाएगा तो रॉकेट किस डायरेक्शन में जाएगा?
Sir, upward.
तो फिर
Sir, but the thrust force is in opposite direction to the relative velocity, right? The relative velocity is 0 in the horizontal direction. So, means, sir, how is there a relative velocity in the...
what's wrong with you यार? This is
Sir,
not the way
moving
you
with the
do
same
it.
velocity और क्या चाहिए?
Horizontal direction में sand particle will have the same velocity as that of the car. हाँ या ना?
Yes, sir.
तो horizontal direction में relative velocity of the sand particle कितना हुआ with respect to car?
0.
तो what will be the thrust force in the horizontal direction?
0.
तो क्या दिक्कत है आपको?
सर फाइनल आंसर क्या है सर?
क्या?
फाइनल
F by mu ln of m naught by m naught minus mu.
हाँ.
Yes.
हाँ सही है. हाँ, ये डिनोमिनेटर में m नॉट आएगा कि माइनस म्यू आएगा?
minus mu. Differentiation of this in the denominator, m naught is constant. Minus mu t with respect to t जब differentiate करोगे तो minus mu आएगा.
ठीक है सर.
Now one of the student is asking, why don't you use directly dp by dt? Why didn't you use this f external is equal to dp by dt? This is d by dt of mv. This is m into dv by dt plus v into dm by dt. As it is used kar lo na yaar. But see, we don't use this because student will not get a clarity of understanding that this is the relative velocity from this. Hence, we derived it from the first principles of conservation of momentum, and f is change in momentum by t. Both I derived. Right? Directly you write this, you will not be able to recognize that this should be VR. You will get V dm by dt. But clarity of VR will come only when you go from the basic definition and its derivation. Hence, we don't directly write this, but we can. Absolutely no issue.
So if you're using this method, we have to make sure that v dm by dt, v is the velocity, like the relative.
Yeah. And the thumb rule told is, along with all the existing forces, add one more force called thrust force. Equate it to mass into acceleration. Along with all the existing forces, add one more force called thrust force. Equate it to mass into acceleration. Right? Along with all the existing forces, add one more force called thrust force. And what will be the direction of the thrust force? If the mass is increasing, direction of thrust force will be in the direction of
the body.
VR.
Relative velocity.
आंसर बोलोगे तुम, इरिटेट करना ही है. अब तक कभी भी पूरा 1 hour क्लास में 1.5 hour क्लास में did I say any time velocity of the body? Relative velocity VR लिखा भी आपने.
Yes.
Repeat 3 times. If the mass is increasing, बोलो मेरे पास पीछे.
If the mass
is increasing,
thrust force is in the direction of
thrust
force is in the direction of
VR.
VR.
What is VR? Relative velocity.
VR is relative velocity.
If the mass is decreasing,
If the mass is decreasing,
thrust force is
thrust
force is
opposite to the direction of VR.
opposite to the direction of VR.
I will not forget this.
I will not
forget
forget this.
Now listen. Rocket propulsion में there is one negative sign which all the textbooks play with. They don't give a very proper explanation of this negative sign. Only one textbook, Kleppner and Kolenko, which you use in your engineering first year, the most standard textbook for mechanics, he writes that very clearly. People will go wrong with this negative sign. बोल के लिखता है. Right? Right from HCV, Halliday, Resnick, everybody quietly they'll introduce a negative sign in between. That's cheating. Rocket propulsion में have a look at this. Mass is being ejected at the rate of dm by dt. I am assuming capital mg force in the downward direction, thrust force in the upward direction. Thrust force upward क्यों लिया यार आपने? Mass
Sir,
is
decrease हो रहा है mass.
relative velocity of the exhaust gas with respect to the
direction.
Down.
और आप relative velocity of what with respect to what will you take? You are writing the dynamic equation for
Capital M.
Rocket.
rocket. So relative velocity of the exhaust with respect to
Rocket.
Rocket.
previously car. Relative velocity of the sand particle with respect to car.
Car.
With respect to car क्यों लिया यार? अब dynamic equation cart का लिख रहे हो, right? Whichever body का dynamic equation you are writing, take relative velocity of the particle with respect to that.
Yes.
Relative velocity of the exhaust gas with respect to the rocket is in
Downward direction.
mass is decreasing. So thrust force will be opposite to VR. So it is in upward direction. Is everybody convinced of the logic till here?
Yes, sir.
Now here my dynamic equation will be Ft minus capital Mg is capital M into dV by dt. Ft will be how much? VR dm by dt. Capital Mg is capital M dV by dt. Now all the textbooks comfortably they introduce a negative sign and some go up to the extent of saying mass is decreasing and they put a negative sign in front of this. Cheating kar rahe ho aap. Mass is decreasing has already been used and incorporated in the fact that if mass is decreasing, thrust force is in
Upward direction.
decreasing बोल के दूसरी बार negative sign कैसा डालोगे यार? नहीं डालना. Agree?
Yes, sir.
Yes.
No, Kleppner answers this very properly. Observe carefully. Capital M is the mass of the rocket. He writes, it is uncomfortable to deal with the two masses in the equation. What is small m? Small m is the mass of the exhaust coming. So he writes, d small m by dt will be minus of d capital M by dt. Rate at which exhaust is coming out will be equal to the rate at which mass of the rocket is decreasing. They both are not the same m. Rate at which the mass of the exhaust is coming out should be equal to the rate at which the mass of the rocket is decreasing. When I am equating both here, I should have a negative sign.
Yes, sir.
Now when you write, you get the answer in two steps. This is the clarity which Kleppner gives. Minus capital Mg is capital M into dV by dt. I'll bring this to the left. dV by dt is equal to minus Vr dm by m. What have I done? I have multiplied all throughout by m and I divided by m and multiplied by dt. Divided by m and multiplied by dt. Do you agree with that? Multiply with dt, multiply by dt, multiply with dt. Divided by capital. Obviously, you know what we do next. At time t equal to 0, I'll call this mass initial. Initial velocity is u. At time t equal to t, mass final. I'm interested in the final velocity. This integral will be v minus u minus Vr ln of this integration will turn out to be mass final by mass initial minus gt. Now I take this negative sign inside the ln v and u I am bringing it to the right. U minus gt I'll keep in one bracket. Vr ln of this negative sign jab inside the bracket to the power minus 1 ले रहे हो, this will be m initial by m final. This is the standard expression for rocket propulsion. That part of the board is not visible. Now it is visible. I took u to the right hand side, u minus gt. The negative sign I took it to the power minus 1. So it becomes mass initial by mass final. If the rocket is deep in the space where there is no gravity, it is remove gt. If the rocket is left the Earth's gravitational space, remove gt. V is equal to u plus this. If initial velocity started from 0, if g is 0 and initial velocity is 0, initially it is starting from rest. It is somewhere deep in the space. You can write the expression as VR, ln of initial mass by final mass.
सर
Make a proper note of it.
सर U0 हम लोग तब लेंगे जब रॉकेट जीरो से स्टार्ट हो रहा है या फिर
Rocket
जब
0 से
ग्रेविटी
start.
जीरो सर जब ग्रेविटी जीरो हो रही है तब उसका वेलोसिटी जीरो होना चाहिए तब हम लोग U0 ले सकते हैं नहीं
नहीं भाई, gravity is 0. You are starting at time t equal to 0 and taking velocity to be 0. That means the rocket is starting from 0 velocity.
अच्छा ओके सर
Actually, also it will start with 0 velocity.
हाँ सर
Instead
मतलब
of this
यस
huge
सर
rocket, very slowly it will start rising.
यस सर
Now the small g value will be changing with time. Mg will be changing with time. As the rocket is moving up at higher altitudes, g value will change. How do you calculate that? We will calculate in the chapter gravitation. Till then in the exam, what do you want me to do? They'll give you the value of g. In this problem, they must give you the value of the g.
सर ऐसा कोई प्रॉब्लम देंगे जिसमें बोलेंगे कि रॉकेट कोई और प्लैनेट में जाता है तो उसका जी का वैल्यू अलग रहेगा?
इतना जोर से बात करोगे, इतना जल्दी बात करोगे तो समझ में नहीं आएगा. आराम से.
Sir, will there be any problems with say that the rocket will go to another planet, hence the value of G will change?
Natural. Once it by another planet, you're sending to the moon. You cross the point field. Somebody says rising for the first few minutes, it will be gravitational field of Earth before it escapes, so it has to incorporate it in the equation, right? Yeah, this is the complete equation or the most appropriate equation. These are approximations. Depending on circumstances, they'll give you this. Need not be that both will be given simultaneously.
G might not even be constant, no? Because if we
Will not
increase
be.
height,
That's what I told you. As the
उसने
height
बोला ना अभी
increases, G will change.
sorry.
That we will deal with in a different chapter. Escape velocity कोई पूछ रहा है will be done in gravitation chapter. 11.2 kilometers per second is the escape velocity to escape from Earth's gravity. Will be derived
Yes.
in the chapter gravitation.
Done, sir.
Now somebody asked, in the right hand side, why didn't you write m minus delta m? Now listen carefully. In the cart, you took m minus mu t. T is a sufficiently large time. T is the sufficiently large time. So m naught minus mu t or m naught plus mu t. Here you wrote the equation for after time t in a short time interval dt. Cart may you are taking after time t in a short time, not you are starting from the initial value.
Yes,
Right? So limits you have changed. Tell me when I can rub the board.
Done, sir.
A chain is falling on a table. Chain is falling on a table. It falls on the table and it comes to rest. It is a perfectly inelastic collision. Originally a Nirdov's problem, picked up even by HCV. A chain is falling on a table. Right? Now listen. Chain is released. It's falling on the ground. Or it doesn't form a heap. He tells you it doesn't form a heap. Why? Because if heap is formed, falling chain on the heap, its force will be diverted in different directions, arbitrary directions, which you cannot decide. Every link of the chain will have a different angle. Every link of the chain will have a different angle. So if it is falling on a heap, the heap will become conical shape. Sand, at least I can tell you it is proper cone. Heap of chain, proper cone bhi nahi ho. Right? So heap is not formed. What is the force exerted on the platform? Question asked is force exerted on platform. 1 second, listen to me. मुझे ये thrust force नहीं apply करना है यार. I want to go from basic principle.
Yes, sir.
I am okay with it. Weight of the chain plus I will write Ft because the small element dm which strikes the platform, it comes to rest. So there is a force exerted, change in momentum on that small element. Do you agree with that?
Yes.
What is the weight of the chain on the platform? Lambda x into g. Say something.
Yes,
Yes,
sir.
sir. Yes, sir.
Sir.
Lambda is mass per unit length. X is the length
Yes,
of
sir.
the
Linear
chain.
mass density.
Into g, the weight of the chain on the platform. I want the force exerted on the platform. Now, what are you telling me this force is about? A small element dm, right, strikes the ground and comes to rest. Small element dm strikes the ground and comes to rest. So change in momentum by time, right? Small element when it is striking the ground, force on it is in upward direction. Force on the ground is in
Downward direction.
Right? Lambda x into g plus lambda dx into v by dt. Lambda dx, this length is dx. Do you agree with that?
Yes.
Yes.
Lambda x into g, dx by dt is v square. So you are trying to tell me the force on the platform is weight of the chain plus lambda v square. Are you trying to tell me the thrust force which you derive Vr dm by dt will land up to be lambda v square? Yes. Readjust the variables. Platform is at rest. Relative velocity will be v dm by dx into dx by dt. Dx by dt is v. Lambda v square. Dm by dx is lambda. This is your thrust force. So far, so good. Yes or no?
Yes, sir.
Sir, apart
No.
from the third,
Pardon?
sir, the thrust force and what is the second element in the equation?
Weight of the chain on the platform. This weight.
Okay. Yes, sir.
Right? Suppose I want to further simplify. Lambda root over of 2gx whole square. Chain is freely falling under gravity.
Yes.
2 lambda gx. Irdo asked you to prove that this thrust force is 2 times the weight of the chain on the platform. HCV is asking you to prove that net force will be 3 times the weight of the chain of the platform. Irdo is asking you to prove that this is 2 times the weight of the chain on the platform. HCV is asking you to prove that the net force is 3 times the weight of the chain on the platform.
Yes.
Both are the same.
Yes, the same.
Now, Olympiad people somewhere in 2007 and 8, they want to verify if you people know that this is the relative velocity. So what they did to the same problem is, the moment you dropped the chain, the platform started accelerating upwards. That means you dropped the chain inside an elevator. The moment you leave the chain, the platform will start accelerating upwards. I'll discuss that. Take it down till here. Subtopic with chain problems. Chain problems in variable mass.
So but इसमें वेरिएबल मास कैसे आया मतलब
बस इंक्रीज हो रहा है ना यार जब वो प्लेटफॉर्म पे आ
जितना
रहा
मास टेबल पे हमेशा सेम थोड़ी ना, तो वेरिएबल मास ही है।
अच्छा ओ
सर बट एलिवेटर लेने से ये कैसे पता चला ओलंपियाड वालों को कि हमको वीआर पता है या नहीं?
That's what they are verifying. If you take root over of 2gx, then you get the wrong answer.
गलत हो जाएगा रूट 2gx.
Yes.
And they asked as a function of time, not x. Here the answer is in terms of x. They just made a small change as a function of time. I'll explain that question first. Take this.
सर फर्स्ट स्टेप में F इज इक्वल टू वो क्या प्लस FI लिखा हुआ FT लिखा हुआ
वेट है वेट
weight WT dot weight
आप वापस बता सकते हो कि
WIGHT lambda x is the mass into g is the weight of this chain on the platform.
So here we took the positive sign of VR because the thrust force acting on the platform is being represented by that. Right?
Suppose you want to look at it that way, have a look. आप this mass का free body diagram draw कर रहे हो, weight इसी mass का लिया हुआ है.
Platform का.
Platform का mass कहाँ दूंगा यार? Chain
अच्छा,
of
okay,
the
sorry. हाँ,
mass
chain
of the
का.
chain on the
Right.
platform.
Yes, sir.
Right?
Yes,
Your free body diagram is for this mass.
Yes, sir.
Right? So the small element dm. So this mass on the platform, is it increasing or decreasing?
Increasing.
Increasing. So thrust force will be in the direction of
The mass.
Yeah.
The VR.
Relative
VR.
velocity.
relative
Velocity.
Relative velocity of this falling element is in which direction?
Downward direction. Yes, sir.
So thrust force will be in the direction of
Downwards.
Yes,
VR.
smart, right?
Yes.
Yes, sir.
sir, can you again explain how thrust force is acting on here?
Small element dm, it collides with the ground and it comes to rest. So there is a change in momentum.
Yes. That is by the thrust force.
Right? Yeah, somebody is asking, is FT an impulsive force? Here, FT is an impulsive force. It will create substantial change in momentum.
Okay, sir.
Sir, lambda x is the mass of the chain, right?
Mass per
लीनियर
unit
मास
length.
डेंसिटी है
ये
वो।
mass per
Per
unit
unit
length.
length.
मार खाएगा अरे बाप रे।
बहुत मार खाएगा, बहुत ज्यादा।
Lambda, mass per unit length, sigma, mass per unit area, rho, mass per unit volume. We decided will be the standard symbols we use till we finish electrodynamics. Yes or no?
Yes, sir.
Yes, sir.
No, forget this, deserve a punishment. $1 मेरा account में लिखो.
सर उससे कुछ नहीं होगा।
इतना कम सर।
और सर
100
DM लिया है चेंज तो
property
लैम्डा
मांगे सर।
मास कैसे हो सकता है, मतलब कुछ भी पूछता।
Sir, if the chain is released from height h, so we just put root 2 g x plus h.
Naturally. Suppose the platform starts accelerating. Use a wet cloth to not be have to wait again for it to dry. Give you the problem till then. Listen. The chain is released at time t equal to 0. At t equal to 0, chain is released. Simultaneously, platform starts accelerating upwards with an acceleration of a. Is this clear? The moment you release the chain, platform starts accelerating in the upward direction with an acceleration of a. After time t, I'll show you that with red ink. After time t, the chain also fell by a distance of half gt square. The platform also moved up by half at square. After time t is shown in red ink, right? After time t, in a short time interval dt, find the total force exerted on the platform. Find total force exerted on platform as a function of time. As the chain is falling, at this instant, find the force, total force exerted on the platform as a function of time. At this instant. At this instant. Will you try or should I discuss?
I will try, sir.
I am waiting. Net total force will be weight plus thrust force on the platform in the downward direction. Do you agree with that?
Yes, sir.
Yes, sir.
Yes, sir.
Weight of the chain on the platform is lambda.
How we
What
did
is
it?
lambda?
So lambda into
What is lambda?
your linear mass density.
Linear mass
dn by
density.
dx.
Like into what is the length of the chain on
Half
the
GT square.
platform?
Half GT
Half
square.
Half
GT square plus half AT
Half
AT
AT.
square.
into this is the mass.
Yes.
G
To get
plus
the
10.
weight, I should multiply the mass with
G.
P.
G plus A.
P plus A.
plus
P plus
A.
Yes,
A.
sir. Yes, sir.
God,
P
Newton's
plus A
first
into
main man in the lift. Lift
हाँ,
is
sir.
going upwards. What is the normal force he experience? M into.
G plus A.
If this platform was moving down, it would have been M into.
G minus A.
G minus A.
G
Don't
minus.
forget this. We learned this when we were born. Just born,
Yes,
rather.
sir. Yes.
Yes.
Right? Plus lambda v square. Thrust force is lambda v square. You just derived. Thrust force is VR dm by dt. This is VR dm by dx into dx by dt. dx by dt is VR. This is lambda VR square. Rather VR square. Don't forget that VR. Lambda by 2 into g plus a whole square t square. 3 lambda by 1. Right? lambda by 2. First part, are you okay with this?
Yes, sir.
VR, relative velocity of the falling element with respect to this chain or the platform. GT minus of minus 8. Relative velocity of the falling element with respect to the chain on the platform. Lambda by 2, g plus a whole square t square. Lambda g plus a whole square t square. This will be 3 by 2 times g plus a whole square t square.
The lambda.
Lambda.
So he lambda.
Can I rub the board?
Yes, sir.
Yes, sir.
Now listen. This is a table with a small smooth hole at the center. With a small smooth hole at the center. You kept a heap of chain on it, and from underneath you pulled a little bit part of the chain and you released it. You slightly pulled and released. You slightly. Initial velocity can be assumed to be 0. Find the velocity of the chain. Yes, lambda is mass per unit length. Find the velocity of the chain as a function of x. Find the velocity of the hanging part as a function of x. थोड़ा ध्यान से सुनिए. I'll discuss this. There is something important. First thing that students get to their mind is loss in potential energy is gain in kinetic energy.
Yes.
Loss in potential energy should be gain in
kinetic energy.
Will be wrong in this particular case. Why? There is a inelastic collision happening. What is it? A small element of the chain which is at rest suddenly starts moving. The heap of the chain is kept on the top. The element which just started moving initially was it?
Yes.
So when there is a sudden change in momentum, there is an impulsive force. And this will contribute to change in kinetic energy because it contributes to change in momentum. So it is an example of inelastic collision. ध्यान से सुनो फिर से. You take a wet lump of clay and throw it towards the wall. It sticks to the wall. It is an inelastic collision. Vice versa. If the wet lump of clay which is stuck to the wall flies out, it is again inelastic. Energy is not conserved. So it is an inelastic collision. Right? A small element of the chain which is at rest suddenly started moving. It is an example of inelastic collision. Energy cannot be conserved.
Yes, sir.
First point. Is this clear to all?
Yes, sir.
Then the only other thing we have learned in mechanics till now for the past one academic year is dynamic equation, work energy theorem, conservation of momentum. Momentum to conserve nahi hoga yahan because there is an external force called normal force, gravity, and here not short time interval. Momentum conservation is eliminated. You are asking me as a function of x. That means you are giving sufficient time. So you cannot even say gravity is non-impulsive here and escape. Momentum conserve nahi hoga. And work energy theorem, energy is not conserved. तो और क्या सीखा है हम लोगों ने? Dynamic equation. तो लगा दो dynamic equation. This is the hanging part of the chain. This is x. This is lambda x into g. This will be thrust force. क्यों भैया? Thrust force का direction कैसा decide कर लिया आपने? Mass of this, you are right, drawing the free body diagram for this. Mass of this is increasing. Yes or no?
Yes, sir.
Yes, sir.
First of all, why should that be thrust force? Small element which is at rest suddenly started moving. So there is a thrust force.
Yes, sir.
Yes. Now direction of thrust force. This mass, you are drawing the free body diagram not for the heat. You are drawing for this mass. Is this mass increasing or decreasing?
Increasing.
Increasing means thrust force will be in the direction of
Relative velocity.
relative velocity. With respect to this point is technically moving down, but with respect to this point, the small element will appear to go upwards. The small element, somebody standing here will see the small element going upwards, yes or no? Because it is at rest.
Yes, sir.
So relative velocity of the small element as seen by this chain will be in upward direction. So thrust force will be in upward direction. मुझे ये याद नहीं रखना यार. I will go from the first principles. Have a look at it. The small element here, which you will call as dm, is experiencing a force in the downward direction. Initially it was at rest. Now it is moving along with the chain. So dm experiences force upwards, downwards. So dm on this will give me a force in
Upward.
both the ways. I will repeat again the direction. ध्यान से सुनिए. This dm element, somebody standing on this chain will feel that dm is going upwards because it is at rest initially.
Yes, sir.
So relative velocity of the small element is in the upward direction. As the mass is increasing, I'll take thrust force in the upward direction. If not, I will go from the first principle. The small element dm which was at rest suddenly started moving in the downward direction. That means on dm force is in
Downward direction.
Forward direction.
so on the chain the force will be in
Upward
Upward
direction.
direction.
as simple as that. Right?
Yes, sir.
Now your dynamic equation is lambda x into g minus ft is lambda x into dv by dt. This equation, is it clear?
Yes, sir.
Why are you using dynamic equation? Momentum conservation नहीं होगा, conservation of energy नहीं होगा, inelastic collision है,
Yeah.
right? Then only other thing that we learned is dynamic equation. These are the only three things we learned for the
Yes,
past
sir.
one academic year. Sounds strange, right?
Yes, a little bit.
Now listen, lambda x into g, thrust force is Vr, lambda v square, we already derived this.
Yes, sir.
Lambda x into dv by dt.
Yes, sir.
This simplification is a bit tricky. I'll give you the first thing. What are you supposed to calculate? Velocity as a function of x. So first lambda cancel out kar do.
Yes, sir.
xg minus v square x dv by dx into dx by dt. Why are you doing this?
Get
You
dv
asked
into
me in
v.
terms of x.
Yes, sir.
You asked me in terms of x. I had no choice. xg minus v square xv dv by dx.
Yes, sir.
dx by dt is v.
Yes, sir.
X into v dv by dx. So far so good?
Yes, sir.
Yes.
Now from this you have to calculate v as a function of x. You have to calculate v as a function of
X.
Yes, sir, quadratic.
quadratic. Try करोगे?
हाँ सर करेंगे.
I'll wait. Take it down till here and find out v as a function of x.
But how exactly do we do that over here? Because dx v square का term आ रहा है.
हाँ सर
हाँ सर, quadratic भी और
cannot
calculus भी
separate
use
that
करना।
difference. हाँ sir, dx v square का कुछ मतलब we can't do anything.
फिर भी तो ऐसे बोलता है कर लेंगे।
An idea changes your
Exactly.
life. You will have to wait for it. Somebody already typed the answer. Under root. You didn't put the under root.
Just a second, sir. एक second.
v dv by dx g क्यों सब्स्टिट्यूट कर दोगे यार? क्या बोल रहे हो?
Acceleration देख के किसी ने बोल दिया होगा.
Acceleration g थोड़ी है. You have a thrust force. If you are freely falling, you will put v dv by dx as g. Here is not freely falling. That's a thrust force. Sir. Some people get this answer by committing a mistake. Right? So, wait a minute. People who assume constant acceleration and
तो
put
कैसा
over
mistake?
2gx, you are actually committing a mistake and you are getting this answer
Sir,
by
product
chance.
rule use आएगा ना?
First take it down till here, I'll tell you. Did you take it down till here?
Yes, sir.
Multiply all throughout by 2x.
हाँ सर हो गया मेरा भी.
क्या बोल रहे हो यार? Multiply all throughout by 2x. Two x square g is 2x v square plus 2x square v dv by dx. I got this to the right. Have a look at this. Can I write this as d by dx of x square v square? D by dx of x square v square. First to differentiate x square, it is 2x v square. Differentiate v square to v dv by dx. Agreed?
Yes, sir.
And the next step is your answer. 2gx dx is equal to d of x square v square. Integrate this. 2g x square by 2 is x square v square. Sorry. This is x square.
2gx.
हाँ
X
सर
cube by 3. So this will go. V is root over of 2gx by 3. How did you get to know that you have to multiply with 2x here? See, when you see this equation, this is one equation with two variables, v and x. One equation with two variables, v and x. Right? So you have to bring one in terms of the other. And that too, you have a differential equation dv by dx. So once you see that, you have to bring it in the form of a perfect differential. I'll try for x into v. For x into v here, this is out of question. Whatever I do here, this is the equation. Whatever I do, I cannot bring it in terms of x into v because I have a v square. Then I tried x into v square. Then I tried x square into v. All three eliminated. Now for x square v square, it works out. Multiply by 2x, I will get x square v square. You mean to say we will have to try all the permutations if this is x to the power 5. Agar x to the power 5 hai, so it is better to leave the problem because you will not be able to complete it in the stipulated time. X square v or x v square or x square v square, you have four options to try. Either express it as a perfect differential of xv, xv square, x square v, or x square v square. One of these four should strike. So there it makes sense that you can attempt. A very old Olympiad question, somewhere in 2003 or 4 they have asked this. Complete assignment.
Okay.
Sir, so this marks the end of center of mass and collisions.
Yes. There is one typical problem from 200 puzzling problems in physics on this subtopic to be discussed, which I will discuss in the next class. Let this sink in. Everything in one go, you will not be able to digest.
Sir, chapter over.
Yes.
Sir,
Then you are given time tomorrow to complete your homework.
Yes, sir.
Thank you.
Thank you,
Sir,
sir.
sir, you converted into perfect differential, right? Sir, I tried it. Sir, when you have circled at that equation, say xg minus v square on the board. So from there, if we cross multiply dx, take v square to the other side and then divide by v, so we can make it d of vx. D of vx is equal to g x dx by v. So from there, how do we proceed? Because we got a perfect.
Cannot proceed. Hence, no, you didn't get a perfect differential there. You're
So
missing on
d,
something.
so d of vx. So you got d of x square v square, right?
Right. You will not
I-
get d of vx. कुछ गलती कर रहे हो. नहीं होगा. xv differential में you cannot express this. यहाँ v square दिख रहा है.
I divided by v square, no?
तो डिनोमिनेटर में तो होगा.
हाँ होगा. So from there we
उसको
got.
किधर एलिमिनेट करोगे?
हाँ भाई. Okay.
We will not start rotation on Monday. I'll solve a few tough problems on conservation of momentum, or I'll discuss some of your doubts so that I buy you some more time. I start rotation, you will feel the heat. You will feel it a lot. Right?
Sir, have
So,
we reached the peak of that graph which you draw?
rotation will
Rotation
be
पे
the
आएगा ना?
Almost.
Last
So,
week.
Most maximum.
Monday, preferably, I'll try to take some doubts so that I'm
Yes.
buying you
Yes.
time to complete your law.
Thanks, sir.
So will you take assignment first or the booklet?
Anything, however, whichever sequence you
Take
prefer.
booklet.
Booklet, I think they can be done in even doubt lectures. So I would suggest I take assignment.
Okay, sir.
Okay.
सर डाउट लेक्चर में बहुत धीरे धीरे चलता है.
हाँ
हाँ,
सर, बहुत
धीरे
धीरे।
सर एक डाउट लेक्चर में 30 क्वेश्चन होते हैं बस. वो हाफ एक्सरसाइज.
No issue. We'll finish off as much as possible. Don't worry.
Bye, sir. Thank you.
Thank you,
Sir,
sir.
it will take another month, right?
Bye, sir. Thank you.
Wish you all a happy weekend.
हैप्पी मकर संक्रांति.
Add a small
Sir,
doubt.
sir, a few classes ago we did a problem where a ball, like a sphere, strikes another sphere and it's connected to a string, so it goes in a circle, like just goes in a vertical circle. And in that problem, when the ball strikes the sphere, you took the velocity root 5gh in the horizontal direction, right? But what I did was I took the component of the velocity of the ball in the x and the y direction, and in the x direction I took it as root 5gh, and the y direction it gets cancelled out by the tension. But that was wrong, so I was wondering why it was wrong.
Can you send that on WhatsApp? Send it
Sir,
to me.
as far as I remember, we had this discussion on our group. वो ऐसा होता है
It's
कि
okay.
मतलब
Send it to me. I'll
component
see and
zero
I'll.
zero
Sir, I have a small doubt in this question on the board.
beta equals
Hello.
Sir, in this one, can you re-explain the direction of thrust with the help of relative velocity again? I couldn't understand.
This man standing on this chain. You're drawing the free body diagram for this.
Yes,
so
sir.
relative velocity of dm with respect to this chain should be taken.
Yes, sir, yes.
dm was at rest. Chain is moving downwards. So this man will feel dm to be moving
Upwards, yes, sir.
Mass is increasing, so thrust force will be in the direction of increasing mass.
Yes, sir. Got it. Thank you.
In the direction of VR.
Yes.
Chalo. See you people in the next class. I'll take up doubts of assignment. Preferably, I'll start with subjective. Assignment ka, I'll start with subjective questions.
Okay, sir.
So,
Sir,
Hello?
HCV भी तो था.
हाँ सर, HCV last 20 problems were left.
Okay, पहले तो HCV कर देंगे.
हाँ सर, आई गेस लास्ट क्लास में आपने एक वो बुकलेट का 30th सम कराया था, उसका मेरे को थर्ड पार्ट वो मैकेनिकल एनर्जी वाला नहीं समझ में आ रहा है. आप
Okay, tell me in the doubt lecture, I'll solve.
ओके ओके.